Okay, but we do need to review. I'm just going to use this page for scratch paper so you can just cross out all the questions because we're not going to go with that. Okay. So when we deal with radicals, we're talking about area of a square, a perfect square. What do I know about a square? What? It has 4 sides. What else do I know about the sides? Yep. They're all the same. They're all equal. Okay. Length and width are the same length. Okay. So if I have a square with an area of 25, what are the side lengths? 5 and 5, right? If I have a square, okay, with the area, let's say 36, what are the lengths of the sides? 6 and 6. What if I have a square with the length of with the area of 20? What are the length of the sides? Okay, that would not be a square then, right? We want a square. They have to match exactly. Okay, we need a number times itself that gives me 20. Does that make sense? What times what gives me 20? Okay, and what that would be the square root of 20 and the square root of 20. Okay, if on my calculator I put in the square root of 20, times the square root of 20, I would get an answer of 20. Okay. But we really don't know what the square root of 20 is, correct? Okay, we do need to simplify the square root of 20, okay, which is what we're going to be working on right now to do. Okay. So we're going to go over here. We have some perfect squares, right? I wrote down all of my perfect squares. So you at the top on the next page, write down all those perfect squares. That'll help me compare and contrast each of these. Okay, so 36 and 3 radical 6, we need to compare without a calculator. We're going to try and do this. Okay. The easiest way to do this is 3. Okay, that 3 is like the length of the sides. If I had a square that had a length of the sides of 3, what would the area be? What's an area of a square with a side length of 3? Are you guys still writing down the perfect squares? Is that why we're... Okay, sorry. Let me give you guys time to do that. Okay, back here. So we're dealing with those square roots. Remember, those square roots or the radicals are simply the area of a square. Okay, so in this case, if we want to compare them, I need to know what the area of the square is. Okay, so if I have a square with a side length of 3, what would the area be? What's 3 times 3? 9. So the area of a square with a side length of 3 would be 9. Does that make sense? Okay, so to make this radical, it'd be 9 times 6. What's 9 times 6? 54. So which one's bigger? 36 or square root of 54? Okay, square root of 54 is bigger. Okay. Any questions over that? Let's talk about this one. Okay, if I have a square with a side length of 6, what would the area of that square be? 36. So this would be, in here, would be 36 times 2. What's 36 times 2? 72. How does the square root of 72 and the square root of 72 compare? They're equal, right? So 6 square root 2 is equal to the square root of 72. Okay. All we did was rewrite this square root of 72 as factors of 36 times 2, and then I have a perfect square. The perfect square of 36 is 6. So 6 radical 2 is just another way of writing the square root of 72. Any questions over that? Yes? Okay, I'll get it for you in just a second. Okay. So what we're trying to do when we're simplifying a radical is take out the perfect squares. Okay, take out all those perfect squares that we have, that we know. Okay, and leave the things that are not perfect squares inside the radical. So for A, we have the square root of 44. We want to find any perfect squares that I have. So it multiplies to 44. That's going to factor it. 4 and 11, very good. Okay. I have a perfect square, right? 4 is a perfect square. What's the square root of 4? 2 times 2. So if I were to write this, here's my square. My area of my square was 44. Since I have that perfect square, the side lengths are 2 and 2. Okay. 11 isn't a perfect square, so I just rewrite it as a radical. Square root of 11 and the square root of 11. Because the square root of 11 times the square root of 11 is 11. So my side lengths, okay, would be 2 square root 11. So if I simplified square root of 44, I would get 2 square root 11. Any questions over that? Okay, we're going to do another example over here. Okay, put square root of 24. Okay, again, I'm looking for perfect squares. So it multiplies to 24. 6 and what? 6 and 4. Oh, good. 4 is a perfect square. So I have 2 times 2. 6 is not, but I can still factor it. 3 times 2. So my square is actually, my area is 24. I can have a 2 on this side and a 2 on this side from my pairs. Does that make sense? 3 and 2, they don't have pairs. So they're just inside the radical. The square root of 3 times 2, the square root of 3 times 2. So the length of my sides is 2 square root 6. Any questions over that? Okay. Let's try this one now. 3 square root 27. Yes. You have it. What do you get? Okay, so you put the 3 inside. Since we're trying to pull things out, we're not going to put it back inside. Okay, but that is what we were doing up here to compare the two. We're not comparing right now. We're just simplifying. If we were going to compare it, then we would do it like that. Okay, on this, we're going to take this 3 and kind of leave it over to the side for now. Okay, the 3 is outside the radical. We're not using it right now. We want to simplify the square root of 27. Yep. 9 times 3. Okay. And what multiplies to 9, class? 3 times 3. Okay, I have a pair of 3s. They get to be outside the radical. I have a 3 that stays inside the radical because it does not have a pair to move on both sides of my square. Okay, another way we talk about this was to do analogy of the radical being in jail. Okay, you get arrested, you go to jail, you need someone to come bail you out, right? Okay, so this 3 has someone come bail him out, so he gets out of jail. This 3, his parents are mad, they didn't come get him, so he's stuck in jail. Okay, so that's kind of how we kind of talk about this, to give us a little bit of a reminder. Okay, now we have to remember back at the beginning, this 3 was on the outside. Okay, so we have to put that 3 on the outside as well. And then we can just multiply those two together. 3 times 3 is 9, and then square root 3. So that would be 3 square root 27 simplified. Any questions over that? Okay, now we're gonna get some variables involved. Okay, we're gonna rewrite it to remove perfect square factors other than 1 and the radicand. Okay. So let's worry about this. There's 2 different ways to deal with our variables. I'll show you both ways. First of all, do we know the square root of 25? Yes, right? 5 times 5 gives me 25, so the square root of 25 is 5. I have x cubed, so that means I have x times x times x. Remember, I need a pair to be the length and the width. So how many pairs of x's do I have? I have 1 pair, right? There's a pair of x's, so it gets to come outside. This x is by itself, so it stays inside the radical. Any questions over that? Okay, B. Again, this 5 is on the outside, so we're going to worry about him later. Okay, in fact, we can just put him over here by himself and then do this simplification. What's 4, the square root of 4, class? 2. So I know I have my pairs that get to come out with the 5. Okay, since I don't really want to write out 17 x's, okay, that's going to be a lot of x's, right? You can, and it'll work, right? But there's got to be an easier way. Okay, do you remember back at the very beginning of the school year when we wrote the exponents as fractions? Okay, they're fractional exponents when you have a root. Okay, the root goes on the bottom, the square root here, so the root is 2. We can simplify that. How many times does 2 go into 17? 8. So that means there's 8 pairs of x's, right? So x to the 8th. Do I have any leftover x's though? 1, right? That 1 doesn't have a pair, so it has to stay in jail. It stays inside the radical. We then multiply 5 times 2 and get 10. X to the 8th, square root 8. Or square root x, sorry. Any questions over that? Okay, let's do a few on our own. Oh, let's answer this question first. How does the exponent of a variable determine if the term is a perfect square? So how am I going to know if x to a certain power is going to be a perfect square? Yeah? How do we know it's going to be a perfect square? Yep. Not into itself, but it can be divided. It's exponents, you guys. What did we have to divide the exponent by? 2, right? If I want a perfect one, what do I know about the exponent? It has to be even, right? X to the 14th will have a perfect square of x to the 7th, because x to the 7th times x to the 7th is x to the 14th. Does that make sense? Okay, so you want it to have an even exponent. Okay, the exponent will be even. Okay, we're going to skip this page for a minute and just try some on the following page, which is page 86. Okay. Okay, do problem 7, 8, and 9. Simplify those radicals for me. Yep. Welcome. Okay, most of us were to factor this. It doesn't matter how you factor it. If you start off with different numbers than what I started off, you're fine. I'm going to move it over here so we can show all the work. Okay, I would use 8 times 10. If you use something other than that, that's okay. So then I factor 10, I get 5 times 2. I factor 8, I get 4 times 2. 4 can still be factored, so 2 times 2. Okay. What I'm going to do is I'm going to put it all inside the radical. That might be helpful to some of us who are still struggling. I have these 2's. I have this 2. I have another 2. And then I have a 5. Okay, put them in order from least to greatest. Does that make sense? Once I factor the 8, 8's gone because I already have all these prime factorizations of it. So then I find my pairs. I have a pair of 2's outside. Another pair of 2's outside. 5 stays inside. No pair. Two times 2 is 4. Square root 5. Any questions? Okay. Try number 11 now. See if you can get 200. Okay, so again, I'm going to move the 200 over here so I have room to factor it. I would have seen, oh, it's, $200, 100 times 2, then 10 times 10. If you see a perfect square right there, you can stop factoring. If you don't see the perfect square, then keep going. 2 times 5, 2 times 5. So when I write this out, it's all of the prime numbers. Okay, all those prime numbers. These are not the numbers because I factored them further. So it multiplies to 200 is 2 times 2 times 2 times 5 times 5. If I multiplied all those numbers together, I'd get 200. Okay, so now we're looking for the pairs. So I have a pair of 2s and a pair of 5s. So 2 times 5 comes on the outside. This 2 stays on the inside. So square root of 200, when I simplify it, should be 10 square root 2. Any questions over that? Okay, so now we have to go on to back to our next page, or our other page. Example 4, so just turn back to 85, page 85. And now we need to multiply. Multiply radical expressions. Okay, when we multiply radical expressions, you multiply the things on the outside together and you multiply the things on the inside together. Okay, they don't mix. Outside stuff doesn't multiply by inside stuff and inside stuff doesn't multiply by outside stuff. Okay. So we're gonna do 1/2 times 4, which is 2. The easiest way to do this is to factor your numbers before you multiply. You would rather have smaller numbers to factor rather than really big numbers. If I multiplied 21 times 7, I'd get 147. And that's a little bit more difficult to factor than 21 and 7. So I'm going to factor the 21 as 3 times 7. So inside my radical, I have 3 times 7 times that other 7. So this comes here, and these come here. And then x cubed and x squared. I multiply those together and I get x to the 5th. Remember, when you multiply things with exponents, you add the exponents. Okay, so now I'm looking for pairs. I have a pair of 7s, so they're going to move to the outside. So I have a 2 on the outside already. Then I have times 7. Okay. Then I find out how many pairs of x's I have. So divide it by 2. Very good. So I have x squared. Inside the radical, I have the 3. And I have a leftover x because 2 doesn't go into 5 evenly. It has a remainder. Almost there. Now I'm just going to multiply. 2 times 7 is 14. X squared square root 3x. Any questions over that? We're good? Next one. Same idea. I'm going to multiply the numbers on the outside together. 2 times 1 is 2. Then I'm going to factor all these numbers. 12 is 2 times 6, 2 times 3. 18 is 9 times 2, 3 times 3. So then I have 2 times 2 times 3 times 3 times 3 inside my radical. And x to the 9th times x to the 5th is x to the 14th. Any questions so far? Okay, find your pairs. Try and simplify that for me. Oh, I'm missing a 2 inside, you guys, right? I should have an extra 2. Give me 1 second. I have 2 times 2 times 2. Then times 3 times 3 times 3, and then x to the 14th. Fix that for me. Wait until we're done with notes. We're almost done. Okay, let's see how we did. I have a pair of 2s and another pair of 3s that move on to the outside. So that'll give me 2 times 2 times 3. Then I divide the 14 by 2. And 14 divided by 2 is x to the 7th. Inside my radical, I'm left with the 2 and the 3. I don't have any leftover x's because x to the 14th is an even amount. So I just multiply. 2 times 2 is 4 times 3 is 12, x to the 7th. 2 times 3 is 6. Any questions over that? How are we doing here? Getting a little easier? Okay. Let's go back to this page. Okay, do number 14 and 15. Then I'm going to factor, which would be 4 times 2, 2 times 2. Inside my radical, I have 2, then times these 2's. Hold on 1 second. Okay, so I have 2 times 2 times 2. So I should have 4 2's inside my radical. Okay, so we have 2 times 2 times 2 times 2, and then we have to multiply our x's. X to the 5th times x is x to the 6th. Have I lost anyone? Some of you guys put a 4 in there from this, but remember, I factored that 4, so it's not in there. The 2 times 2 gave me that 4. This is the prime numbers, the last numbers in your rows. Okay? So then you find your pairs. I have a pair of 2's and another pair of 2's. I divide the 6 by 2. So that gives me 2x squared times 2 times 2 times x cubed. Is there anything left in the radical? Nope. There's no more 2's leftovers. And then 2 can go into 6 evenly for the exponent. So I just multiply this all together. 2 times 2 times 2 is 8. X squared times x cubed is x to the 5th. So that's it. Find your mistake. Fix that mistake. Any questions over that? Okay, number 15. 10 is 2 times 5. So I have the 3 that's on the outside. On the inside is 7 times 2 times 5. X times x to the 7th is x to the 8th. I don't have any pairs of numbers. 7, 2, and 5, no pairs. So that they're all staying inside. I can divide the 8 by 2, and it goes in evenly. So I'm going to get 3 times the x to the 4th power. And inside of my radical, I'm going to multiply 7 times 2 times 5, which is 70. Any questions over that? We're all good? Okay, we're going to have about 15 minutes left in class, so I'm going to have you guys work on your homework or your take-home